Dear student, I am Mr. G.V. Pujari, working as an assistant professor in Sharan Stop Technology College of Engineering. Today we are going to learn about foundry casting process. So basically when we start any kind of process, first we are going to see about the introduction. So when we can consider the number of processes, you can see there are so many kinds of processes for manufacturing any kind of component. One is the casting process, another one is the machining process, and one more process is joining process. So these three kind of process we can be able to manufacture any kind of component. So one by one, step by step, first of all we see what is these processes. So first process is casting process. In casting process, exploit the fluidity of a metal in liquid state as it takes shapes and liquefies in a mold. It's the primary manufacturing process. So casting process is basically we are going to cast any kind of component. First of all, we are going to melt the material and then we are going to pour into a mold. And from that we are going to make a casting. Another process is machining process. So machining process is nothing but provide desired shape with good accuracy and precision, but tend to waste material in the generation of removed portion. So basically when you learn machining process means we are going to remove the material from any kind of components, or we are going to remove the materials from raw material. So we are required to take a raw material of the desired properties of the material, and that material we are going to remove the material step by step as per the drawing. So machining process we can say it is a material we are going to remove and then we are going to prepare as per the drawing what we want to actual prepare a product. Then another process is joining process. So what is the joining process? Joining process is nothing but permit a complex shapes to be constructed from simpler components and have a wide domain of application. So joining process, it is like a permanent joining. You can be used nut and bolts for joining purpose, or we can be used welding processes. Here you are going to join a two components or two different kind of materials you are going to join together. Okay, so joining process is another process where you are going to prepare a component. So these are the three processes we have seen here. By using these processes we are going to complete any kind of product. Next, so today actually we are going to learn about the foundry process or casting process. It is also called it's a casting process. So first of all we are going to see what is the steps of the casting process. Okay, so any process whatever you want to complete, they are having some kind of certain kinds of steps. So first of all we will see steps to be followed for a casting operation. So here first of all we require to making a mold cavity, then liquefy or melt the material by properly heating it in a suitable furnace. Then liquid or molten metal is poured into a prepared mold cavity. Allowed to solidify, product is taken out of the mold cavity, trimmed and made to shape. So these are the steps basically we are going to use for preparation of component in casting. Means first of all we require to prepare a mold, then we require to prepare mold. Means what actually what component you want, desired component, that components we will take the shapes of that in prepare in a mold. Okay, it is a reverse kind of shape in a mold of that component we are going to prepare. Then which type of material you want to prepare, that material we require to first of all melt. Okay, for melting purpose lot of type of furnaces we can be used. There can be electric arc furnace, there can be a cupola furnace, induction arc furnace. So lot of types of furnaces are available in industry. As per availability in our foundry we can be used that foundry, that method of for melting purpose, and then we are going to prepare a liquid metal. Okay, so second step is important to prepare a liquid metal. Then whatever the molten liquid metal, that we are going to pour into a mold cavity. So as early as possible we require to pour this liquid molten metal into mold, because if you are not poured early, then it is going to start solidification. Okay, so if it solidified earlier before you are pouring, then it cannot be, your part is not going to completely filled, and half filled part you can be able to prepare. Okay, that's why earlier we require to pour the molten metal into a cavity. After that, once you filled your mold cavity with your molten metal, the next step you require to wait for solidification. Okay, as we know that every material requires some time to cool, because whenever you are going to melt that material, your solid material is already converted into liquid metal. Okay, so liquid metal you have poured into a mold cavity, and then we are going to solidify this metal. Okay, so that kind of whatever part you have prepared, that part we are going to do a solidification. Okay, so we require to wait for solidification of that part. So, okay, so it will take some kind of time as per the material required time. Okay, so once your material is solidified, then you can be take your product out. Okay, means that you can break the mold, you can break this is a sand mold, and you can take your product outside. Once you taken your product outside, there can be a excess material is present on your component. Whatever the excess material is present on your component, that we are going to trim them. Okay, that component whatever present excess, that we are going to trim, and then you will get your final component. Okay, then some kind of things we require to take care of this while we are preparing or while we are doing this process of this foundry. So one important thing is preparation of mold of patterns. So whenever we are preparing mold, also important thing is we require to take care of the pattern. So pattern means whatever component you want to prepare, that same kind of component we first of all require to prepare in terms of pattern. So one more important thing, first thing we require to give the attention towards your preparation of pattern. Second, melting and pouring of the liquefied metal, solidification and further cooling to room temperature. Second, one more important thing we require to attend here is melting of the your metal. Your metal must be required to be completely liquefied, and whatever the liquefied metal, as early as we require to fill into mold. Okay, once you filled into mold, then afterwards we require to wait for cooling purpose. If proper cooling is not takes place, again there can be a chances of defects can be takes place. Okay, so there can be chances of defects can be takes place. Because of that, we require to wait for some time for cooling purpose at room temperature. Okay, so that is the important thing, we require to wait at room temperature. Then next thing, last is again one more important thing is defects and inspection. So whatever the components you have prepared here, also we require to check for inspection for defects. So many kinds of defects can be takes place inside your component. There can be having emptiness into your component, means that component is unfilled region may be present inside that. So whether component is having any kind of stresses, okay, any kind of loophole is present inside your component, that we require to check. There are so many kinds of inspection methods. X-ray radiography is one of the method. Then dye penetration is one of the method. By using dye penetration inspection method, we can be able to check surface defects. If there is a having any kind of surface defects on your component, that can be checked by your, we can be able to check by dye penetration. And X-ray radiography we are using for whatever kind of any kind of inside defect is present in your component, that we can be easily able to detect. Okay, so these are the very much important thing we require to consider while we are doing the inspection, that time whether any kind of defect is present. Because if defective part is we are going to use, then your component will not give you good kind of service. Okay, so that's why defective parts earlier we require to remove from your okay quantity. Okay, so then next thing we are going to see That is advantage of casting process. Whatever the things, any process is always having some kind of advantage. Okay, so for this casting process, one important advantage thing is molten material can flow into very small section so that intricate shapes can be made by this process. As a result, many other operations such as machining, forging and welding can be minimized. Okay, so very any kind of complicated shape you can be able to prepare by this process. Okay, so many kinds of complicated process or complicated components we require to prepare in industry. Okay, so once you prepare properly mold of that component, you can be able to cast that part into foundry. Okay, so this is one more important advantage of this process, possible to cast both ferrous and non-ferrous materials. So here we can be able to cast a ferrous metal also and non-ferrous metal also. Another advantage is tools are very simple and expensive. They're not very much expensive here. So tools are very simple and very expensive. You can be used, you can be prepare the tools and you can be able to prepare a mold. So whatever required tools are very simple for this process. Then another advantage is useful for small lot production. So this process can be useful for small lot production and weight reduction in design. So whatever the design process, in design you can be able to reduce the weight of the component. So these are the advantages of this casting process. So when there is a having advantage of any process, also there is a having limitation of any kind of process. So like the same thing, casting is also having limitation of the process. First whatever the limitation is, accuracy and surface finish are not very good for final application. So whatever the accuracy, whatever we are getting here, that is not as equal to machining process. Okay, so surface finish and whatever the quality is not as equal to your machining operation. Difficult to remove defects due to presence of moisture. If there is a moisture is present inside your sand or component, then it is very difficult to remove the defects. Another limitation is metal casting is a labor intensive process. So many kinds of, when there is no any automation in industry, everything we require to do by hand. Okay, so manual labors we require to use in a industry. So because of that, it is we require to depends on the labors. Automation question, because for doing automation it required huge investment in foundry. That's why it is always question for semi-scale industry person or small scale industry person to do the automation. Okay, because automation required huge kind of investment for that and cannot be affordable for a medium scale industry person. Okay, the application of this foundry process, it can be applicable for preparation of cylindrical blocks, wheels, housings, pipes, belts, piston ring, machine tool, beds, etc. So like this, there are so many kinds of another applications are also present. For that, few application I have mentioned here. Okay, so whatever we have learned about the advantage and disadvantage, what is the steps and application of the foundry process. So next step we are going to see the typical sand mold, how the sand mold looks like. So on the screen you will see this is a typical sand mold. Here this is a parting line. So upper part of this parting line, this is a cope, and the lower portion of this parting line, this is a drag. Okay, so in cope how many things are present? This is a pouring basin, then this is a vent, this is an open riser. So this is a flask, it is a outside present. So inside this flask, all the sand or whatever the mold of cope and drag we have prepared in this flask. Okay, and this is a sand, whatever the mold we have prepared, this mold we have prepared by using a sand. Okay, then this pouring basin means what? Whatever the molten metal we are going to pour, that we are going to directly pour into this pouring basin. Whatever the liquid metal you are going to pour here, that is going to come from this side and then they are going to go from downside. Then this is a runner for flowing your metal, then it is going inside your mold cavity. This is your mold cavity. Okay, this is a core. If suppose if we want any kind of holes inside your component, then we are going to prepare a core. Okay, so here these are the mold cavity here. So these are the actual components we are going to prepare here. Whatever the flow, whatever the liquid metal going to come from this inside, it's going to come here, and then it is going from this upside. And open riser, from observing from outside, you will see this whether your liquid metal is reached inside or not. If this is a fill, if you see the liquid metal here in open riser, it means that whatever the liquid metal we have poured from this basin, it is reached into your mold cavity. Okay, so whatever the liquid metal we have poured here, that is whether reached in mold cavity or not. How we are going to check? By observing this open riser. Once you observe the open riser having liquid metal, it means that whatever the liquid we have poured here, that have reached inside your mold cavity. Okay, one more thing we have shown here, that is a vent. So why vent have shown here? Vent means nothing but very small section holes are provided here. So why these holes are provided, tunnel like holes are provided? Because whatever the gases are found inside this cavity, because your molten metal is hot. Okay, because of hot molten metal, there can be having gases, flames, whatever the gases are generated inside that, they are going to come outside from this vent. Okay, so they are going outside by using this vent. So number of vents we have provided inside your mold, so that these gases are not going to trap inside your component. If they are trapped inside your component, there can be a possibility of generation of a empty voids inside your component, so that whatever the strength of your component is going to reduce. Okay, so this is the typical sand mold we have prepared, or we are always preparing for your foundry operation. So thank you very much for listening carefully this lecture. So in this lecture we have learned about the what is mean by foundry process, what are the steps in the foundry process, what is the advantage, disadvantage and application of the foundry process. And then also we have seen in this lecture about the what is a typical mold, what kind of things are provided into typical mold. So thank you very much. Again another lecture we will see whatever the happening in the mold, what is mean by pattern, we will see in our another lecture. Thank you very much.